All right, homework out from last night. Asked you to do page 56, numbers 24 through 26 at the top, and numbers 1 through 12 at the bottom. 1 through 12 is kind of a general review of stuff, and then the 24 through 26, a little bit more practice with the adding, well, actually, I guess one of them was subtracting fractions. The rest of it was more of a algebraic representation, or a little bit of algebraic representation, a little bit of order of operations on the tail end. All right, so let's start with the 24 to 26, and number 24. We've got this subtraction problem. We've got a negative 2m, positive 7, all over m squared, positive 11m, negative 12, and all minus a 13m, positive 6, over m, positive 12. And let's start with Maddie. Anytime we've got polynomial denominators, Maddie, we've got to either factor or group. Okay, so can I factor this? Looks like I can. What would I factor it into? All right. And what about the m positive 12? Group it because it doesn't factor. I do want to draw attention, though, to this negative sign. That's going to be important. So once I've factored or grouped everything, we go to the big long line. Kendall, what do I write below it?
m plus 12 and minus 12.
All right, and then above the line, I've got to see what do I change here to then change up here as I move it down. Genesis, what changes from here to here? Nothing. So from here to here, yeah, just leave it negative 2 and positive 7. However, from here to here, Michael,
you got to add the m negative 1.
Or technically multiply the negative, put it up there, right? Is what you meant, right? Put the m negative 1 up there, and that means we're going to have to multiply these two and do what, Michael?
Add the negative.
Right, change those signs as I copy them down. So to multiply binomials, how do I do that, class? Foil, right? Multiply binomials, just using FOIL. And so first gives me what, Michael?
Negative 13m squared.
Good, initially 13m squared, but Michael, remember, we're changing those signs. Negative 13m squared. What about the outer inner? What does that give us, Abby?
Negative 7m.
And then we're going to change the sign and make it up.
Positive 7m.
And then finally, Brandon, we're going to multiply the last to get. But change the sign, so positive 6. Good. And then, Audrey, we're done changing all the numerators and stuff. We just need to simplify by
Combining.
And now if I were to go descending order, I'd have to put the 13m squared, negative 13m squared first. I don't want to put that first. So let's go ascending order instead. Now let's start with our constants. Combine to give us 13. And then the plain old m's combine to give us positive 5m. And then we'll end with the lonely. If there were any chance of this factoring, I would try to factor and see if I cancel with something, but there's no way you're splitting this up to get that, so either of these. So we'll keep the m plus 12, the m negative 1, and there's our answer. How many have this for number 24 on the homework? Have this answer. Audrey, good. Kendall, good. Questions? Questions. Anyone just forget to combine like terms? Or maybe you had this but forgot to actually combine the terms together. How many forgot to change the signs and that threw you off? Okay, a couple of you there. Questions, comments? Questions, comments? All right, let's take a look at number 25. How would I represent the sum of the quotient of x and y and the quotient of x minus 23 and y plus 12? What do you think, Maddie? Well, let's see. It says the sum. So what do I start off with putting? A plus sign, right? So I'm going to add some things together. There's going to be something here and there's going to be something here. I'm just going to add two things together. And the first thing, it says the sum of the quotient of x and y. So now I'm going to get an x over y here. And then the other thing that's on the other side of the plus sign is the quotient of x negative 23 and y positive 12. And if you had to add these the way we were doing over here, it would, draw a long line, put your y plus 12, blah, blah, blah. But we don't have to do all of that because it just wanted us to leave this. How many got this as your initial representation? All right, then, Maddie, it said if x is 3 and y is -7, evaluate. Well, if I plug in 3 and -7, my first fraction becomes -3/7. Then the next fraction, when I put in my 3 and my -7, becomes -20 over +5, which this I can divide evenly, class, to get -4. So I have -3/7, and then I've got a -4. Well, don't make this too hard. If I were to take, I don't know, let's think pizzas. If I were to take 3/7 of a pizza, and then I took 4 more pizzas, class, I have taken 4 3/7. And you could just get -4 3/7. Or you could multiply top and bottom by 7, get -3/7, -28/7 to get -31/7. And you could leave the answer that way as well. Either answer is acceptable. How many got one of those answers for 25? Move this out of your way. Questions on number 25? Question. All right, number 26. And Kendall, how would I represent 12 less than the sum of x squared and z squared?
X cubed plus z squared minus 12.
Good. X squared plus z squared minus 12. 12 less than the sum of x squared and z squared. And it says if x is -4 and y is, or z, excuse me, is 5, what's the value? Well, obviously we have to square the -4, Kendall. What question?
It's cubed. X cubed.
Oh, x cubed. That does make a big difference. Kendall, what's -4 cubed? -64. What is 5 squared?
25.
25, and of course we have this -12 at the end. I'm going to combine the two negatives first. -64, -12, class? -76, and then we'll add them together to get -51. How many had -51? For your answer. Good, several of you this time. Questions on this? All right, let's drop down to the 1 through 12 at the bottom of the page. Just some basic review of concepts here, exponents and such. And number 1, let's go to Genesis. What did you get when you multiply? Q to the 7th, w to the 9th, plus q cubed, w cubed. Good, q to the 10th, w to the 12th. Number 2, they don't want denominators. That means I'm going to have to be stuck with these negative exponents, still adding the exponents as we multiply. What'd you get for number 2, Michael?
48 a to the -4th, b to the -10th.
Perfect. 48 a to the -4th, b to the -10th. Number 3, raising a power to a power. We got to multiply those exponents, Abby.
X to the 15th, y to the -20th, z to the 60th.
Perfect. X to the 15th, y to the -20th, z to the 60th. Number 4, class?
1.
1. Number 5, got a division problem, subtracting exponents, Audrey.
5k to -4th, r to the 15th.
Good. Initially, you get 5r to the 15th over k to the 4th, right? But because it said no denominators, we have to move that k up, k to the -4th. Great job. 5, k to the -4th, r to the 15th. And number 6, Brandon.
V, negative, m to the negative, and z to the -6.
I'm not quite sure. I think you might be misreading your own writing. Maddie? Good. 4m to the -2nd, z to the -6th. You said something about a v or something. I'm not...
No, I
misread, but yeah, should have been a 4 when you divide the numbers, and then m squared in the bottom moves up as m to the -2nd, z to the 6th in the bottom moves up, z to the -6th for our answer there. Questions 1 through 6? Anyone perfect 1 through 6? A couple of you. Anyone just miss one? All right, questions. Number 7, rewriting that expression using the commutative property. Let's go back to Brandon. What does that mean, the commutative property? Good. Switch it around. You're sticking the same thing. So how would I write that using the commutative property? Yeah, and although everything in my being is like I really want to switch the n and the y, since it only wanted the commutative property of addition, if I did that, that would show the commutative property of multiplication. They didn't want that. So technically 3yn plus p, but yes, it bothers me that the y is before the n. What about number 8, the distributive property? Let's go to Kendall.
xy plus xn.
Or technically...
xy plus nx.
There we go. That makes me feel much better. xy plus nx. The book has xn in your defense, but they would be minus a point. All right, questions on that? Questions on that? All right, number 9. More practice with what we looked at, 25 and 26. 4 more than the quotient of w plus 4 and w minus 2. What did you write for that, Genesis?
W plus 4 over w minus 2 plus 4.
There we go, perfect. And it said w is 6, I think? No, w is 6. So if w is 6, we plug that in 10 fourths. I guess that's 5 halves. 2.5 plus 4 gives you? If w is 6, what do you get for your answer?
4
That is, okay, initially, yes. So you get the 5 halves here, right? 10 fourths becomes 5 halves plus 4. Does give 4 and 5 halves, but it's awkward to leave a mixed number that includes the improper fraction. So let's go and change 5 halves to a mixed number. Would that be mixed? 2.5, right? 2 goes into 5 twice with 1 left. And then 4 plus 2.5 gives us a simplified answer of 6.5 would be the better answer. Or put this over 1, multiply top and bottom by 2. Make this 5 halves plus 8 halves equals, class, 13 halves. Or, on your calculator, you can do 4 plus 5 halves. Let me show you. Get your calculators out. If you have a calculator like mine, it's going to be really easy to show you. And you can do it with me. If you have a different calculator, I can try to help you figure out your specific calculator. But do you see right down here in the bottom corner, right above this little back arrow, that's actually a delete key. So if you type something wrong, and like, wait, I didn't mean it, hit the backspace key or the delete key. But right above it's the fraction button. So if you were to do 4 plus, and then 5 fraction 2. Now you'll see how your calculator, like mine, it can't make a slanted line. So it does a backward L for a slant. Okay, it's their best approach to a slant. So you should see 4 plus, and then you'll have 5 fraction 2, and it equals, and it gives you 6, a spacer, that's what that is, 1, and then there's that weird backwards L slanty fraction bar thing, 2, 6 and 1/2. So you can put it directly on the calculator and let it do all the work for you. Feels good to be in 10th grade. Anyone have a different calculator from mine, not able to follow along? All right. Let's take a look at number 10. And Michael, the product of x squared minus 3x plus 2 and x plus 7x minus 10 divided by 4. Yuck.
I got negative 50.
Well, I'm not looking for the answer. I'm looking for how do we write it.
Oh, you draw a long fraction mark.
Really long,
Put a
yep.
4 underneath it. And then you have the quantity of x squared minus 3x plus 2 times the quantity of x squared plus 7x minus 10.
Good, and then you've got to plug in, it says x is negative 2. Let's see, we could probably do a lot of this in our head. When we square a negative 2, class, we get
4.
Positive 4. And then we've got negative 3 times negative 2 gives positive 6 plus 2. So this whole big set of parentheses becomes what value, class? 12. And again, you could plug that into the calculator if you needed to. All right, then over here, once again, we square the negative 2, class. 4. And then 7 times negative 2.
Negative 14.
Negative 10. What does that second set of parentheses become, class?
Negative 28.
Negative 20. Right? Negative 24. Add the positive 4 to that to get negative 20. And then we'll divide all of it by 4. The nice thing is you could cancel the 4 with either one of these beforehand. So I'll cancel the 4 with, say, the 12 to get a 1 and 3. And then it's just 3 times negative 20, class gives
Negative 60.
negative 60. Or 12 times negative 20 on the calculator. By the way, your negative button is right here next to your equal sign. We see the positive to negative, just hit that, it just keeps changing whatever you have on the screen from a positive to a negative, back to a positive, and back and forth. But negative 60 should have been your answer. How many had negative 60 for number 10? Okay, just a couple of you. Questions on this one? Be careful on the work there. Number 11 is a fun one. Let's go to Abby. How do we represent the difference between d cubed negative 4d positive 5 and d cubed positive d squared negative d positive 2 times the sum of d and 1? Whew.
So I did d cubed negative 4d positive 5 with parentheses on that.
Right.
Negative and then parentheses. d cubed positive d squared negative d positive 2.
Okay, so this whole thing, she has just represented the difference between this and that. Then it says all of this entire difference as a group.
I put brackets on it.
Perfect. Brackets around all of this, or another set of parentheses. Then it says times.
And then parentheses d plus 1.
Times the sum of d and 1. Wow. Fantastic job, Abby. Anyone else get this correct? With all the great job, Brandon as well. Maddie as well. Excellent. Those who didn't, questions on how all the little pieces and parts fit together? All right, this is a doozy. And then d is negative 3. They couldn't have given us like d is 0. That would have been really nice. The answer wouldn't have been 0, but it would have been a lot easier. So d is negative 3. And let's see, Abby, let's see if you go perfect here. What'd you get for your answer?
Negative 6.
That is correct. You two that also had it, did you get negative 6? No. So we got the representation correct. Here we get a negative 27. Here's a positive 12. Negative times negative. Plus 5. Minus. And then here we're going to cube it again to get that same negative 27. This is a positive 9. Then minus negative 3 gives positive 3, positive 2. So that's all inside the brackets. And then out here, negative 3 plus 1 just gives negative 2. Remember, we never really subtract. We add the inverse here. Now we don't need the parentheses anymore. For that matter, we don't even need the plus anymore. And now I can cancel the 27s away. These 9 and 3 together are negative 12, cancels with a positive 12, so it becomes 5 minus 2 is 3. Times negative 2, and there's the negative 6. Okay, questions on that? All right, let's see, number 12. Easier compared to the last one. The sum of that and that decreased by 20, and let's go to Brandon.
Q minus 1 plus Q squared minus 4Q minus 12 minus 20.
All like that? Not like that.
No.
Okay?
And hit the parentheses with the Q minus 1. And Q squared.
Like that. Good. This is correct right here. However, since both sets of parentheses are preceded by positives, even if he didn't have the parentheses, he wouldn't be entirely wrong, because that's what it becomes as well. Let me put my plus sign back that I accidentally started to erase a moment ago. How many had that? How many had what Brandon had with the parentheses, preferably? Again, even without, technically it works out okay. I'm going to combine some like terms here before I evaluate. I'll put my q and negative 4q together to get negative 3q, and combine all these negative numbers together to get negative 33. That way, when I evaluate for q equaling 5, I've only got a couple places to plug it in. Square it to get 25. 3 times 5 is negative 15. Negative 33 gives us what answer?
I got negative 23.
Negative 23 is our answer. How many had that for number 12? Okay, so not one of our greatest performances on homework, but to be fair, it was a little bit more challenging than some of the stuff we've worked on before. Welcome to Algebra 2, right? Questions? Questions on this? All right, let's move on then. We've been working with fractions or rational expressions. We've been working with adding fractions. Said you have to have class A, common denominator. And we've been working with reducing fractions where we said we only cancel factors. We never cancel terms. Next section notes. Let's talk about multiplying fractions. Multiplying fractions. And this is going to be much, much easier. Multiplying fractions is going to be much easier than adding fractions because you don't have to have a common denominator. Just consider this for a moment. Go back in your mind to your younger days when you used an x for a multiplication symbol, for instance. 4/15 times 5/12. And your teacher would have told you, class, we could, when multiplying fractions, multiply our numerators together. 4 times 5 gives 20. And if you have your calculators out, 15 times 12 gives, right, 180. And then we can reduce the fraction. And what is 20 1/180ths reduced to? 1/9. And then the teacher said, oh, but class, there's a better way. We can reduce as we go. And she would point out that, presuming it was a she, that the 5 and the 15 have a common number you can divide out of both of them. We can cancel something, class. a 5. Cancel out a factor of 5 to get 1 and 3. Similarly, the 4 and 12 have a factor of 4 that can cancel out to give us 1 and 3. And there's no need to get big scary numbers. We just multiply a third times a third to get a ninth. But she did probably emphasize, don't ever cancel side by side, class. Right? You never cancel denominators or numerators. You only cancel a numerator with a denominator. How many remember learning that kind of stuff when you were in elementary school, way back when? We're going to do the same thing with algebra. Write this example in your notes if you would. A squared b over c. A squared b over c, if I can copy down what I said, times c squared d over ad. We could multiply straight across and then reduce, but it's going to be quicker, I think, if we'll reduce as we go. What is some numerator factor and some denominator factor that you see that could cancel with each other? Audrey?
A's.
This a cancels with one of these two a's to leave me with a single a up here. What else is something we see that'll cancel? Michael?
C.
This c with one of these two c's to leave myself with
C.
C. What else, Maddie? Or is that all? There's one more thing that'll cancel.
Do the D's?
The D's. Now, normally we call it reducing when you cancel straight up and down, but they'll cancel each other, right? As long as it's numerator with denominator. We're used to diagonal canceling, right? But straight up and down canceling is just reducing. You can do that as well. So what's left in the top class? A, B, C. And in the denominator class, we just have technically 1. Do we have to write it over 1? No. So if everything cancels in the bottom, we don't have to write the denominator. Though, what if everything cancels in the top? Do we have to write the 1 for the numerator? Yes, better write the 1. So when in doubt, just write the 1. But just like reducing fractions, because that's kind of what we did, if something disappears from the bottom, like we see here, we have to set it unequal to 0. So here we'd say that A can't be 0. C can't be 0. And some would argue D can't be 0. Though if you look at the answer, you're like, what D is it exactly that can't be 0? So you know, I could see both ways on the D can't be 0, but at least the A and C can't be 0. So very similar to reducing fractions. It's just you're reducing more stuff now. Questions on this? Look at page 43 now in your textbooks. Turn back, page 43. And look at the example problem with the little letter b next to it, if you would. They're on page 43. Notice the first fraction is x plus 2 over x negative 5. Nothing to see here. Look at the next fraction. Oh, we can factor some stuff. Notice they backwards foiled the perfect square trinomial. So instead of x minus 5 squared, they wrote x minus 5. My recommendation as well. And then they backwards foiled the denominator x minus 7, x plus 2. Notice they canceled the x plus 2's. Notice they canceled the x plus 5's. By the way, I would have grouped the x plus 2 and x minus 5 just to see it. We know the fraction bar groups, but I would have grouped them as well. And notice their answer is simply x minus 5 over x minus 7. But x plus 2 disappeared from the denominator. X can't be negative 2. Notice x minus 5 disappeared from the denominator. X can't equal 5. Questions on what they did on letter B. All right, so write these steps in your notes. Step number 1 to multiplying fractions is to factor or group all polynomials. Factor or group all polynomials. This is kind of like what we were doing with reducing fractions. Very similar. With adding fractions, we would factor or group denominators specifically, but with multiplying fractions, any polynomials, you factor or group them. Step number 2, cancel. Numerators with denominators. Cancel numerators with denominators. Once that's finished, anything that's left in the top, you just multiply it all together. Anything that's left in the bottom, you multiply it all together. So we multiply across. Multiply across. And if we did it right, we shouldn't have to reduce, by the way. Because the reducing should have taken place in the canceling step. The last thing is remember to write excluded values. And you might remind yourself, excluded values are those factors that cancel out of the denominator. Whatever cancels from the denominator ends up being those excluded values. Questions on this? Again, really it's like reducing fractions 2.0, right? There's just multiple fractions that can help each other to cancel more stuff. So it's twice the fun. Questions on that? Turn over to page 47 now. Turn over to page 47. And number 17, write it down in your paper very quickly, 3y over 8 times 4 over y. I see no polynomials. That means I don't have to factor anything. You already have factors. Okay? So if you see no polynomials, that means everything's already factors technically, so you can cancel stuff. What cancels here? Brandon?
The y's.
The y's cancel out. What else?
4.
The 4 in the 4 and the 4 and the 8 cancel to give us
2. 1 and 2.
1 and 2. What's left in our answer class? 3 over 2. Now, what canceled out of the denominator? The y. Technically a 4, but we already know 4 can't be 0, right? But the y canceled. So normally we would specify y can't be 0. Now again, I could make a case for why should you even state that there is no y left at all anyway. But the book states it, whatever. I don't really care, since it's not there anymore anyway. Questions on that? Does that seem pretty straightforward? No, not straightforward. Yes, straightforward. Sorry, I thought I saw a head shake over here. We good? Okay. Number 19. Write that one down. We got a 12, a to the 9th, u to the 9th, u to the 7th over 15c. And multiplying that by a 3, c to the 4th over 21, a to the 13th, u to the 8th. Again, there are no polynomials. You see no pluses and minuses, which means we have no terms to worry about here. Everything's already factors. Let's cancel stuff. What cancels here? Audrey?
The a's.
Okay, I've got 9 a's up here to cancel with 9 a's down here to leave me with how many a's, class? 4 a's in the denominator. By the way, do the a's disappear from the denominator? I don't need an excluded value. Would it be wrong to say a can't be 0? No, you just don't need to. All right, what else cancels? Kendall? The u's cancel. 7 u's here, 8 u's here to leave me with? A single u in the bottom. Again, I don't have to make any qualifying statements about the u because it's still in the denominator. I don't care if it's gone from the numerator, it's just the denominator I worry about so much. Genesis, what else?
15 and 3.
The 15 and 3. What cancels out of both, of course?
3.
To get 5 and 1. All right, what else, Michael?
The c.
The c cancels here and here to leave me with
C to the cubed.
c cubed in the numerator. Now, c did disappear from the denominator. That's an excluded value I'm going to have to write. In fact, if you want to, write it down now that c can't be 0. Wouldn't hurt, right? All right, anything else cancel here? Anyone see anything? Yeah?
Is it 3?
There is a 3 in the
12 and 27.
12 and 21 to get.
4 and 7.
4 and 7. All right, anything else? Now here's the fun part. Not missing anything. What's left in the top? Genesis?
4c cubed.
4, 1, and c cubed, which when you multiply gives, as you said, 4c cubed. What's left in the bottom, Genesis?
35 a to the 4th.
Good. 5, 7, a to the 4th, and u. So 35, a to the 4th, u. And we already wrote our excluded value. And there we go. We're done. Questions on this one, number 19. It seemed pretty straightforward here. All right, number 21. We're not going to write it down the way it is in the textbook. The first fraction, we'll write it down, but what am I going to do to those polynomials, class? Group them. So I'm going to put the x minus 3 in parentheses, and I'm going to put the x minus 7 in parentheses. Don't waste your time writing that next fraction down. Do the factoring in your head. How would I factor the second numerator? Michael?
There's a 7 and a 5 and 35.
Right, 7 and 5.
Your sign is a negative.
Both signs negative, right? Of course, don't forget the
X.
x is good. What about the denominator right below it, Maddie? You say x minus 6, x minus 3? x plus 6. Okay, I misheard you, sorry. X plus 6, x minus 3. And yes, now the outer inner checks out. Again, do all that backwards FOIL in your head. And so now we get to cancel stuff. And obviously, what cancels, class?
X minus 7.
X minus 7s.
X minus 3.
X minus 3s. So all that's left for my answer.
X minus 5 over x plus 6.
There we go, where I need to specify x cannot be two things. 3 or
7.
7. I'm going to write it like this. X can't be 3, comma, 7. Rather than writing x can't be 3, x can't be 7, because I'm too lazy for that. And there's our answer. Questions on this? Do we feel like multiplying fractions way easier? Like, where has it been all my life? All right, write this one down if you would. X squared positive 2x over x squared negative 3x times, next numerator, x squared negative x negative 6, and then x squared positive 4x positive 4. Take just a moment at your seats, multiply these two fractions together. And this one is loads of fun because when you factor, the x's cancel, the x plus 2's cancel here, the x plus 2's cancel here, the x minus 3's cancel, nothing's left, right? Except technically what's still in the numerator, class? A 1. What's technically in the denominator? 1. So 1 over 1 just becomes 1. If you want to write this down in your notes, if everything cancels, your answer is 1. If everything cancels, your answer is 1. Now, do you still need to say that x can't be negative 2, 3, or 0? Again, I would argue, what x are you talking about that can't be 0, 3, or negative 2? There aren't any x's left, right? But the book specifies, can't be those things, I suppose. But again, I would argue if you don't see an x left, why should you say anything about an x that doesn't exist, right? All right, this one, don't copy it down as I've got it. Go to the factored form. Don't copy it this way. Copy it down in the factored form. Remember, if you can't factor, group it. But only mess with polynomials. How many copied it this way? How many copied it down like this? Factor out a common factor difference. The squares grouped it and left it alone. What cancels, class? A minus 2x's. A plus 2x's. 15 and 5 you get 3 and 1. What's left? 1 over 3a. Good, Brandon. Where we need to specify what about the a, class? Can't equal 2x or negative 2x. And one way we could say this is a cannot equal positive negative 2x. Or you could say a cannot equal 2x or negative 2x. But I prefer this because I'm lazy. I would rather write less. Your homework for this evening is to do page 47. Page 47. Numbers 20, 22, 23, 25, and 26. Page 47, numbers 20, 22, 23, 25, and 26. Also on page 56, do numbers 17 and 18. Page 56, do numbers 17 and 18. One more time. Page 47, 20, 22, 23, 25, 26. Page 56, numbers 17 and 18. And we'll continue working on multiplying fractions in our next lesson. Have a wonderful rest of your day. You are dismissed.